Welcome to Krishi Hospital. This is agriculturist SF Ahmed here, and in this channel we discuss about problems and solutions related to agriculture and agricultural science. As you saw from the title, I am here to discuss about a biological data analysis method called ANOVA. But before going to that, if you are new to this channel, please consider subscribing and hitting the bell icon so that you get updated when we upload a new video like this. So, let us begin. There are a lot of things to know about data and data analysis, but do not freak out. I am not going to give you any long boring lecture about what is data, what is its classification and these other stuff, but I do want to give you 3 important key points that you need to remember before jumping into any kind of data analytical software. Then I will take you to the computer screen for ANOVA. Now, these 3 things are: what is the type of your data, what do you want to analyze, and what you want your reader to understand. Now, the type of the data has to do with the selection of the analytical software. This would tell you which software to use for your particular analysis. This is very common among students that they just jump into any kind of popular analytical software they have without giving a single thought that whether that software is right for them or wrong. Different softwares are made based on different algorithms, and that is why they are specialized in analyzing a particular group of data. For example, SPSS is good in analyzing social data. Take another example of R that has specific packages for specific data analysis. So, if you take your data to a wrong software, you might get some results, but that might not be what you were looking for. So, you got your software correct. Now, it is time to select your analysis. Let us say you have a data set of leaf number of 10 plants. You want to know the average leaf number. So, you go for analyzing mean. If you want to know the variation among plants, then you go for comparison analysis. This is simple as that. So, you have got your analysis done as well. Now, it is time to present the data. This is the place where all kind of weird stuff happens, because there are a lot of data presentation methods to choose from: bar, chart, graphs, tables, plots and so on. Mistakes of using tables in place of graphs or charts in place of plots are very common, but these silly mistakes can easily be avoided if a little thought is given on where you want your reader to focus. Let us say you have analyzed the difference in leaf number of 10 plants, and now you want to show the comparative difference. If you choose a table to present the data, it should look like this, where the reader can see only the numbers, not the comparative difference. But if you choose a bar graph, then it should look like this, where you are guiding your reader to focus on the comparative difference rather than individual data, and the reader can easily understand which one is the highest and which one is the lowest. There are a lot more on proper data presentation method. If you want us to make a separate video on different data presentation methods like bar graph, point plot, radar plot, histogram, dendrogram, etc. and so on, so please put a comment below in the comment section, and we would try to get back at you on that. Or you can join our Facebook group to discuss about your data related problems. Our group members would be more than happy to help you on that. The link is in the description, so be sure to check that. Now, let us go to the computer screen for ANOVA. So, here we are at the computer screen. We will start right away. Just to remind you about the 3 important key points, I have my data set here. So, this is the data set of plant height and grain yield of 10 wheat varieties. This data set is actually from my master's experiment in 2019. I have had total 17 parameters and 18 varieties, but for simplicity I have included only 2 parameters, 2 treatments and 10 varieties. Now, let us dissect the data. This is the serial number of the genotypes from 1 to 10, and this is the name of the varieties, and this is the number of replications. So, for those who do not know what replication is the number of the repetition of your experiment. So, if you repeat your experiment twice, then you have 2 replication. If you repeat your experiment 4 times, then you have 4 replication. For my case, I have repeated my experiment 3 times, so I have 3 replications. And then the other, you see the data. So, this is a general parameter type data. So, any kind of general parameter analyzing software would do great for my analysis. So, that is why I am choosing Statistix10. You can do it with Statistix7, Statistix8 or maybe NTSYS, etc. and so on. For the second point, I would like to pull out the relationship among the variables. For that, I will do ANOVA, because ANOVA pulls out the relationship between dependent and independent variables. So we have our data set here. We cannot just go ahead and directly import this data set to Statistix10 and start analyzing. Let me explain it to you a bit. Statistix10 is a software that can only read numbers, not names. I have my variety names here. If I upload these names, then Statistix10 will not be able to read it, rather it will show me some errors. This is where data formatting comes in. Every software has its own way of data formatting. For Statistix10, it can read only numbers, so these variety names should be replaced with numbers, and also the same for the treatments. So in the first column, I already have denoted a number with each of the variety. So I can simply replace the name of this variety with the number. So if we do this for the whole data set, then the data set should look like this. Now what we will do, we will import our data to Statistix10 and then start analyzing ANOVA. So this is what the interface of Statistix10 looks like. Now we have to import the data. We can import it two ways. We can simply copy and paste the data. Or we can go to File and select Import. Keep in mind, only two types of file can be imported, Excel or text. So your data set must be either Excel or text file. As I said earlier, we can just simply copy our data. So we select our data and then we copy it and then paste it. So we have our data set here. As I am interested in pulling out the relationship among the variables, so I'll do ANOVA. So it should be in the statistics. Let's go to statistics. There should be analysis of variance. Here it is, analysis of variance. So under this tab there is some other options that is called completely randomized design, randomized complete block design, Latin square design. These are basically the design of experiments. A short spoiler here, we will be doing a separate video on experimental design, how they work, which one to select for your experiment, and what is your experimental design if you are not sure about it. So be sure to subscribe and hit the notification bell so that you get updated when we upload that video. I will also put the link in the description, so please sure to check that as well. Let's get back. If your experiment was in completely randomized design, you select that one. If it were in Latin square design, you select that one. So whatever your experimental design is, you have to select that one. For my case, it was RCBD or randomized complete block design, so I select this one. After selecting your design, a window should pop up like this. Let's see what the window says. At the left side, we have our genotypes, treatment, replication, plant height, and grain yield data. In the right side, we have three empty boxes. So what we have to do, we have to transfer our variables into these three boxes. So let's come from the bottom. The bottom one says treatment variable. There is no mistake, our treatment should go into the bottom box. Let's put our treatment in the bottom box. On top of that, there is block variable. Here my replication variable represents block variable. So our replication variable should go to block variable. Now in the first box it is saying dependent variable. So in the dependent variable section I put my plant height and grain yield. Now let's click OK. And here you will be greeted with your ANOVA results. I did it for only plant height and grain yield, so I have two separate tables with the grain mean and coefficient of variation. If you want to save this result, you can simply click the save icon in the top left of the window, or you can just select, copy and paste it in an Excel file. That would also save your results. So, that was how to do ANOVA in Statistix 10. Now, go ahead and give it a try. I have given the dataset in the description if you want to test it out. Give this video a thumbs up if you like it and share it among your friends so that they can also benefit from it. Subscribe to stay on board till we catch you later.